Data type refers to the amount of memory space needed to support it. In general, there's half a dozen data types that are native, like integer, float, doubles in C, C++, strings, chars. Some of those belong to C++, which is more advanced than C, and all the other refer to what's available in C. Typically, when we say atomic type, these are what we call primitive, meaning they already exist. It's already built inside the C compiler. They already understood. They are integers, floating points, and characters. These are typically 1 byte each, and you can use these type by spelling them out like this, lowercase. Integer is roughly 4 bytes. Char is 1 byte. Float is typically 8 bytes, or at least 4 bytes, 4 to 8, depending on the operating systems. This is very fundamental primitives that are available in C right away. You don't have to import any libraries or pound define anything or pound include anything at all. Let's move on to the next. So these are space designations, the amount of memory spaces required to host these things. As we know, each byte is 8 bits, which means integer has 32 bits. 32 bits means the number of variations in terms of your integer is 2 to the 32. But if you take into negative integers and positive integers plus 0, then you'll have to divide this up. And typically that leads to 0 in the middle, 2 to the 32 minus 1, divided by 2 minus 1, and 2 to the 32 divided by 2 in this directions. Same thing with long, short. They all have different amount of memory space requirement. The bigger the space it is, the more amount of data you can store inside, which means long double has a very big capacity, just like double. And you can store a lot more information in these bigger data types than integer itself, which is only 4 bytes. Short is even smaller. This is 16 bits, so on and so forth. So generally in C, there are integers, there are floating points, and also characters. One thing about char is 1 byte, which is 8 bits. This means you can store 2 to the 8th various different characters. And usually you see them in ASCII chart. Half of those characters are the ones that you can see on your keyboard. Let's move on. In this example, we see a couple things. One is the declarations of your integer. This assumed to have been declared somewhere as an integer, since this one doesn't have any decimal. I is an integer. You also have a for loop or while loop, which is the control structure we're talking about, and this is the conditional statement. So there are several things involved in this example. This is using I, checking to see what it is, and depending on whether the ith items inside your X, this is not the ith item, this is actually I plus 1 item because array indexing starts with 0. Whether this one is equal to this, blah, 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 and then checking to see if I is equal to 100, and then you can set other variables, so on and so forth. Let's look at assignment operators next. Assignment operators, as the name implied, is the equal sign. This equal sign simply assigned the value of expression into a variable, and this is what's called the R value, which is something that could be evaluated into a value, and the variable is what's called L value. This L value typically connotes to something that has a memory space associated with this. There are more formal definitions of L value and R value, but suffice to say, variable on the left side, expressions on the right side. An example is this, where you have x equals 5. You cannot do 5 equals x because x is a variable. And this variable occupies a memory space. Therefore, it needs to be an L value, not R value. R value, on the other hand, is a value or an expression that evaluates into a value, which must be on the right side, R value. You can also have arithmetic expressions in the expression that we saw earlier. This could be referred to as if y is x, this could be x plus equals 1. So you can shorthand this. You can also have embedded assignment with parentheses, and this is the level of precedence or the order in which certain parts of your expression could be evaluated first. having parentheses means y equals 7 takes precedence over the plus sign, which means this will be evaluated first. So it's this prior to the plus sign. There's various different ways you can write these things. This is the unary operator we talked about earlier. Let's look at input and output. So typically in C, we use scanf and printf. Scanf for input, printf for output. Input is coming from the users. This could be any signals from your keyboard device, or it could be audio. And printf is a way of sending the signal to your console window. One example is a terminal in Mac. And when you do a printf, specifying the format and the type associated with the format you wish to print, this entire payload goes into your terminal or your output. Scanf, on the other hand, takes a buffer, and this buffer needs to be an address or the address of the buffer. So it's imperative to understand that there's actually an ampersand sign. This ampersand stands for address of. Remember when we say memory cloud, when a variable is declared, namely this num, when declared, it's simply just an integer, because we know this is an integer through scanf. If num is an integer, it occupies a 4 bytes memory address located at this location, and num is simply the identifier for that memory location. Or you can think of this as a label for that location. And this location has a memory address, let's say 0 times FZ2. That is hexadecimal, which represents the address of num. So as part of the API specification for scanf, you must include the memory address of your buffer, and not the buffer itself. Lots of students make the mistake of eliminating this, and it does not work, because num is simply the identifier, not the address of this memory location. So please bear in mind the use of this ampersand. This is super important. Again, I must highlight this to reiterate the importance of having the ampersand sign. And ampersand precedes identifier. And this identifier must have a type associated with this. If you don't have type, then you cannot declare this thing. By way of not having this thing declared, you're not going to even have a memory address associated with this. So that's how this works. Let's look at Boolean operators next. There's a whole lot of chapter about this, including all of the relational operators and logical operators. You must know how to use them. Relational operators evaluates to true or false. So this is normally used in the context of conditional statement, like if and else, where you have the parentheses open and closing with a conditional sitting inside. A condition could be something greater than or less than or equals to. These evaluates to true or false. So is logical operators. Logical operators and or not. If you, for example, have an and in between, in C++ it's ampersand. Let's say if you have false and false, this evaluates to false. However, if you have a true and false, it's still false. False, true gives you false. The only way where and will evaluate to a true is when both left-hand side and right-hand side were to true. And that gives you a true. So this is what we call truth table. You must know this in your grade school. If not, something that is very basic in a logic class where you can pick up those things. You also have at the end a conditional operator. So this is not a conditional operator. This is a ternary operator, which is shorthand for two operations. One is to evaluate a condition of something and something. If this condition is true, then the flow of control will evaluate this expression number one. If not true, let's say condition is false, it will then go here. So this is true, this is false. You can also attach an assignment operator in front. So this is truly a ternary. There are three things that must be evaluated. One is the condition. The second one is assignment of the evaluation for the expression either 1 or 2. The third one is the assignment, the overall result that goes into this max. So if you look this carefully, this max is simply going to get either x or y depending on the condition of whether x is greater than y or not. Hope that makes sense. This video will end right here. We'll create separate videos for other topics.